So in this chapter, now I'm going to talk about some of the key concepts and the buzzwords that are used in industry. So then you also know what these buzzwords or these concepts actually mean. These are some of these I did not cover in my earlier chapters. I hope you already understand things like vector database, or embeddings. Those I think we already covered. But I'm going to cover the concept that I had not discussed earlier. So first one is RAG. You'll hear this term very often. RAG stands for Retrieval Augmented Generation. What RAG is, it actually combines the capabilities of large language model and the information that anybody has in their organization or institution or university or private place where there is information in their databases or documents. So it combines the capabilities of LLM and the information that you have in your organization to generate the intelligent results. And this is a cost-effective way of doing it without having to train LLM on all the data that you have. That's what RAG does. So at high level, RAG has two sections. One is called data preparation, and data preparation is where um, the data that you have in your organization, for example, in WEX, we have data about transactions, we have data about people's benefits plans, or mobility data, or legal data, or finance data, or marketing data, or consumer data. All the data that we have in our organization, that data needs to be prepared for LLM to use, to be able to generate the answers if we ever decide to design, or if we design a chatbot that answers questions on our internal documents, our internal information, right? And I'm sure we have different entities are building this right already. Um, so data preparation is one part of it, and second part is actually retrieval augmented generation, which actually combines the information that LLM has with the information that we have. So in data preparation, the first step is taking the raw data that we have. Data could be our visual text data, or voice data, or documents that we have. All that data, raw data, is taken, and actually it goes through something called data extraction and chunking. And chunking is essentially creating the you know specific size chunks of the information that we have. Let's say if you have PDF document, then one chunk, let's say PDF has 15 pages, then you can say that I want to separate this 15-page document into 15 chunks. Or you can say this 15-page documents can be chunked into 30 different chunks. And chunk is just a one specific size of the information of your documents, of all your information. You chunk that information, and then for each of those, you generate embeddings. Embeddings is, you already know, these are set of numbers that represent the certain information. And then that information is put in vector database. Then what happens is, on the right side in retrieval augmented generation, let's say if somebody asks a question to a chatbot, that question, say, is a prompt that goes, and then that question is also translated into the embeddings, which are vectors, the numbers, and then that information goes to the vector database. This vector database already has the information that from your organization, that you chunked that information, created embeddings, and put in vector database, right? So this prompt also came to the same vector database. Now there is something called cosine similarity that is used to find the best top chunk of all the chunks that we have. Then using that topmost chunk, the embedding or the prompt is enriched. So prompt now has a better context. So prompt has a question, And with the prompt, we provide more context using the chunk that is information from our organization, and that is passed on to the LLM. That goes to LLM. LLM has its own intelligence. That is, so LLM uses this context from our documents, its own intelligence, and provides a very intelligent response to the user. That's what RAG does. So at high level, RAG is a cost-effective way to improve LLM output without retraining the model on our data. So instead of training LLM on our data, we use RAG to essentially get the result that we want. That's what RAG is. Now, if you go one next step further, what is agentic RAG? RAG, agentic AI is a big thing now. You should all read about agentic RAG system that uses AI agents to solve the complex problems by combining the RAG that we talked about on previous slide with different agents. So now in this case, the agents can actually talk to the RAG, get like one agent can get a query, submit the output to the RAG. This agent can submit its own output to the RAG, and this agent can benefit from the output that was provided by these two different agents to generate an intelligent response. That's what agentic RAG is. It's essentially setting up a RAG pipeline for agents to use. That's what agentic RAG is. Now, let's go to next concept called multimodality. You'll hear people talking about it. It's a very simple concept. Multimodality is nothing but one AI system that uses or combines multiple type of data. So in this diagram, you can see data can be visual data or spatial data or gestural data or oral data or linguistic data. Combining multiple types of data and allowing AI to perform complex tasks on these different types of data and generate more accurate results or predictions. That's what multimodality is. Then prompt engineering, you hear that very often. Prompt engineering is actually art of designing the prompts that generate the accurate results or most effective results. There are concepts like prompt recipe, prompt libraries. They allow you to create a specific role for LLM to play. Those recipes allow for you to chain different prompts. So there are a lot of things in it, but at core, it's just the art of designing proper prompts that generate appropriate results. You'll hear one more, you'll hear many times people talking about something called LangChain. LangChain is nothing but it's a framework. It's a development framework that allows you to combine the models, the agents, the chains, the prompts, indexes, all that um, to create agents that are capable of reasoning about the issues and breaking them down into smaller tasks. And then once it breaks down those smaller tasks, it allows you to chain those tasks or agents to solve complex problems together. That's what LangChain is. It's a development framework for you to create, separate out a large task into smaller tasks and chain those appropriately so you can generate smaller agents to perform different tasks and generate a specific output that you desire. A lot of times now you all heard about DeepSeek. DeepSeek is a competition to Transformer or OpenAI or Google. They recently created a lot of buzz about a very efficient, architecture that they created. It is actually efficient architecture. They don't use Transformer. So DeepSeek uses a architecture called Mixture of Experts in MOE. You can read about it, but at a high level, what this architecture is, that if you see on this diagram, instead of like in Transformer, every transformer is used, every parameter is used, every weight is used to be able to generate certain output. In here, DeepSeek, the input goes to something called gating network, and gating network decides which expert path to choose or which experts to wake up for this type of task instead of asking everybody to work on. That's why it became efficient. So within DeepSeek has around 671 billion parameters. Parameters, think of it just a knowledge point. Um, it actually wakes up or activates only subset of the parameters depending on what the request is. That's how DeepSeek is very, very efficient. But DeepSeek is generally very good for technical tasks or mathematical problems. It probably isn't as good as transformers for retaining the context or linguistic challenges or questions. So again, both have their advantages and disadvantages, but I just wanted to lay out what DeepSeek is, what that architecture is. You should definitely read more about it if you're interested. Mr. Musk, Elon Musk also came up with one more called Grok 3. This is yet another LLM architecture. The top three capabilities that I believe it has is it has advanced natural language processing. I'm sure OpenAI is also building something similar. So I don't think the advanced natural processing would be a huge differentiator. One of the key differentiator though is that Grok 3 uses real-time information. And I'm sure others are also working on it, but currently I don't think Geometry has that. And Growth 3 claims that it specializes in scientific research support. So it's built on advanced transformer architecture. It's still transformer architecture, but it's a little advanced is what Growth 3 is claiming. And it's trained on diverse data set, including scientific research papers, real-time information, and specialized knowledge bases. That's what Grok 3 is claiming, yet to be seen. Then Hugging Face. We all should talk about Hugging Face. It's a popular library. I think all of you should take a look at it. If not, go through different models that they provide. They have over 1 million models that you can try and leverage. Uh, that's a that's a very diverse set of AI models. It's basically a community and a library of AI models. It has a lot of AI applications also that you can use for image processing, video processing, text generation, language translation, speech synthesis, 3D modeling. There are a lot of different applications there that you can try out. I absolutely like this community. The demo that I showed you early on, I used all the models from Hugging Face for that demo. So I just wanted to explain you what that is. Of course, OpenAI also is a platform. You can leverage that. It serves as a bridge to OpenAI machine learning models, and you can read through different APIs that you can consume, and it will give you access to GPT-3, GPT-4, various tasks that you can perform. One more concept that you'll hear a lot is called explainable AI. Explainable AI is a field of study that is focused on creating AI models that are not just powerful in executing tasks, but also explain why why did it make certain decision, how did it do that. And you may wonder, why is that important? Now let's take example. Let's say in WEX transaction processing system, let's say tomorrow we decide to build a AI system that approves or declines payment transactions. Um, and let's say now our GSO organization would need a way to be able to answer the questions to customer. Why was my transaction declined or approved by your AI system? We can't just say, hey, our AI system decided, I don't know. That's not the right way to answer it, right? So our GSO organization would need a way for them to be able to explain to the customer why their payment transaction was approved or declined and why did our AI model do that. So that's what explainable AI is. Explainable AI means not only making decision, but be able to explain why that decision was that way. So these are some of the key concepts. There is one more called federated AI model. You'll hear this a lot. Federated AI model is essentially multiple devices or multiple systems actually work together collaboratively to train the AI model. For example, let's say in WEX, let's say there are three different business units. or not just business units, say 3 different departments, and those 3 different departments have data that is private to them. They don't want to share that. For example, legal team doesn't want to share the information with other teams for right reasons. Let's say there is a GSO organization, there is a technology organization. They have some data that is limited to their teams uh, for whatever reasons. Now, let's say they want to train one model using all of that data without having to share that data with each other. So you can do that by collaborative learning, and that collaborative learning allows model to be trained on this different set of data without need for sharing that data. And this is very critical in where the privacy is critical, or areas like finance, healthcare. So that's what the federated AI model is. I think that's about it about the buzzwords or key concepts. I'll get into the next chapter soon, but this was about the key concepts and the words.